Hello guys, welcome back to the channel. Welcome back to Math Plastic. In today's video I'm going to be showing you how to evaluate functions of multiple variables. So we're going to look at how to get the output when the specific inputs are given. Now what I mean by the evaluation of functions of multiple variables is to just find the functional value of the function when the inputs are given. So considering a function of several variables, function, let's say m, defined on x and y to be equal to 2x plus 3y plus y squared. Considering this function, you would be given inputs as points in the xy coordinate plane. You need a point that is two values, one value for the x and one value for the y. When these inputs are given, you need to substitute this value into the expression for you to be able to evaluate the functional value. So for example, if you are given x to be equal to 2 and y to be equal to 2, it's essentially telling you that you should evaluate this function at the point 2, 2. And what you do is to just substitute the 2 for the x and another 2 for y. So you'll be having 2 multiplying 2 plus 3 multiplying 2 plus 2 squared. And this will simply give you 2 times 2, which would give you 4, plus 3 times 2, which should give you 6, plus 2 squared, which should also give you 4. And this should be equal to 4 plus 6 should give you 10, plus another 4, that's 14. So essentially the functional value at the point 2, 2 is 14. Now to make things a bit clearer, let's consider the same function again, but with different points given. Let's consider the same function m of xy. By this time, let's evaluate this function as a point 1, 3. Again, the key thing over here is substitution. All you need to do is to substitute the corresponding value of x and the corresponding value of y anywhere in the expression that you see x and y. So anywhere in the expression, if I see x, I would substitute 1. If I see y, I would substitute 3. So based on this expression which is given, m of 1, 3 would simply be equal to 2 times 1, since x is equal to 1 in this case, plus 3 times 3, since y is equal to 3 in this case, plus 3 squared, since y is equal to 3 in this case. And this should simply give you 2 plus 3 times 3, which is 9, plus 3 squared, which is also 9. And this should give you 9 plus 9, which is 18, plus 2, that should give you 20. And the functional value at a point 1, 3 should be equal to 20 for this particular function that I've given. To start off really well with our study of Calculus 2.0, we will need to understand how these functions are evaluated. And that's the main reason why I'm doing this video before anything else. So the first thing we should know is that it's very simple. Just like how we have single variable functions where we substitute the value of the variable given to get the value of the function at that variable, we'll do the same thing over there. If you are given a point as the input, the point will depend on the number of independent variables that the function has. So if I have, let's consider a function f defined on a, b, c to be equal to a plus b plus c squared, I would be asked to evaluate this function at a certain point, at a certain input value. And that input value would be a point because it would be a set of all the values of a, b, and c. So let's say I'll be asked to evaluate f at 2, 1, 3. In this case, 2 would be the value of a, 1 would be the value of b, and 3 would be the value of c. So anywhere you see a, just put a 2 there. Anywhere you see a b, put a 1 there. Anywhere you see a c, put a 3 there. And then you simplify the expression you have, solve this, and then you get the functional value at that point. Very simple. This will be 3 plus 9, and this should give you 12. Yes, And that's it for this video. If you enjoyed this video, please leave a like behind, and thank you all for watching. Subscribe if you're new around here, and I'll see you guys in the next one.